STEM Solutions. Discover yourself.
Hello human aliens, welcome back to STEM Solutions. Let's get started with today's episode of Science Updates. Galaxy-sized observatory sees potential hints of gravitational waves. Scientists have used a galaxy-sized space observatory to find possible hints of a unique signal from gravitational waves, or the powerful ripples that course through the universe and wrap the fabric of space and time itself. The new findings, which appeared recently in the Astrophysical Journal Letters, hail from a US and Canadian project called the American Nanohertz Observatory for Gravitational Waves. For over 13 years, nanogravity researchers have pored over a light streaming from dozens of pulsars spread throughout the Milky Way galaxy to try to detect a gravitational wave background. That's what scientists call the steady flux of gravitational radiation that, according to theory, washes over Earth over a constant basis. The team hasn't yet pinpointed the target, but it's getting closer than ever before. This anticipation first hints of gravitational wave background suggest that supermassive black holes likely to merge and that we are bobbing in a sea of gravitational waves rippling from black holes merger in galaxies across the universe. Curiosity rover reaches its 3000th day on Mars. It's been 3000 Martian days or sols since Curiosity touched down on Mars on August 6, 2012, and the rover keeps making new discoveries during its gradual climb up to Mount Sharp, the 3-mile tall or 5-kilometer tall mountain it has been exploring since 2014. Geologists were intrigued to see a series of rocks benches in the most recent panorama from the mission, stitched together from 122 images taken on November 18, 2020. The mission's second 246th sol, the panorama was captured by the master camera or mast cam, which serve as the rover's main eyes. Towards the center of the panorama is the floor of Gallic crater, the 154-kilometer wide bowl that Mount Sharp sits within. On the horizon is the northern crater rim. To the right is the upper part of Mount Sharp, which has rock layers that were shaped by lakes and streams billions of years ago. Scientists make sustainable polymer from sugars and wood. Scientists from the University of Bath have made a sustainable polymer using the second most abundant sugar in nature, xylose. The reliance of plastics and polymers on dwindling fossil fuels is the major problem, and bio-derived polymers, those derived from renewable feedstocks such as plant, are part of solution to make plastics sustainable. This polymer is particularly versatile because its physical and chemical properties can be tweaked easily to make a crystalline material or more of a flexible rubber, as well as to produce a very specific chemical functionalities. Until now, this was very difficult to achieve with bio-derived polymers. This means that with this polymer we can target a variety of applications from packaging to healthcare or energy materials in a more sustainable way. Researchers developed new one-step process for creating self-assembled metamaterials. A team led by University of Minnesota Twin Cities researchers have developed a groundbreaking one-step process for creating materials with unique properties called metamaterials. The results show the realistic possibility of designing similar self-assembled structures with the potential of creating built-to-order nanostructures for wide applications in electronics and optical devices. General metamaterials are materials made in lab so as to provide specific physical, chemical, electrical and optical properties otherwise impossible to find in naturally occurring materials. These materials can have a unique property which make them ideal for a variety of applications from optical fibers and medical devices to aircraft soundproofing and infrastructure monitoring. Usually, these nanoscale materials are painstakingly produced in a specialized clean room environment over days and weeks in a multi-step fabrication process. In fact, the team demonstrated a process for the first ever self-assembled tunable nanostructure to create metamaterials in just one step. The researchers were able to tune the ability to store electrical charge property within a single film using temperature and laser wavelength. They effectively created a variable photonic crystal material with 99% efficiency. Melting icebergs, key to sequence of an ice age, scientists find. Melting icebergs in the Antarctic are the key, say the team from Cardiff University, triggering a series of chain reactions that plunges Earth into a prolonged period of cold temperatures. The findings have been published today in the Nature from an international consortium of scientists from universities around the world. It has long been known that ice age cycles are placed by periodic changes of Earth's orbits of the Sun, which subsequently changes the amount of solar radiation that reaches the Earth's surface. In their study, the team proposed that when the orbit of the Earth around the Sun is just right, Antarctic icebergs begin to melt further and further away from the Antarctica, shifting huge volumes of fresh water away from the Southern Ocean to the Atlantic Ocean. As the Southern Ocean gets saltier and the Northern Atlantic gets fresher, large-scale ocean circulation patterns begin to dramatically change, pulling carbon dioxide out of the atmosphere and reducing the so-called greenhouse effect. This in turn pushes the Earth into ice age conditions. NASA test of Megamoon rocket engines cut short. NASA conducted a test firing of the engines for its giant space launch system SLS lunar rocket on Saturday, but they shut down earlier than they planned, the space agency said. The hot fire test at the Stennis Space Center in Mississippi was supposed to last a little over 8 minutes, the time the engines would burn in flight, but they shut down just over a minute in the burn. Teams are assessing the data to determine what caused the early shutdown and will determine a path forward. The SLS rocket is intended to launch the Artemis mission that will take US astronauts back to the moon. Scientists identify nutrient that helps prevent bacterial infection. Scientists studying the body's natural defenses against bacterial infection have identified a nutrient, taurine, that helps the gut recall prior infection and kill the invading bacteria, such as Klebsiella pneumoniae KPN. The finding, published in the journal Cell by scientists from 5 institutions of the National Institute of Health, could aid efforts seeking alternative to antibiotics. Taurine helps the body digest fats and oils and is found naturally in the bile acids in the gut. The poisonous gas hydrogen sulfide is a byproduct of taurine. The scientists believe that low level of taurine allows pathogens to colonize the gut, but high levels produce enough hydrogen sulfide to prevent colonization. During the study, the researchers realized that a single mild infection is sufficient to prepare the microdata to resist subsequent infection, and that the liver and gallbladder, which synthesize the stored bile acid containing taurine, can help develop long-term infection protection.